This is the prep packet video for Unit 3, Chapter 8.5, and now we're looking at objective number 2. With this objective, we are looking at applications that involve distance, rate, and time. And one of the things that is coming up a lot in these problems, it's not your basic rate times time equals distance that we looked at before. Now we're adding something else to it. And these problems involve a lot of boats and airplanes. And what you really need to realize with this is that the boats in question are on a river that has a current. And if the boat is going downstream, the current is adding to the speed of the boat. So if you're going downstream, the current is adding on. The boat is going upstream. It has to work against the force of the current. So the speed of the boat will be less because it's going against the current. The same with an airplane, although, an airplane's flying through the air. There are what they call tailwinds, which push the plane. And so it's the speed of the plane plus the speed of the wind. And there are headwinds that the plane has to fly against. So it's the speed of the plane minus the headwind. And that's a really important thing that if you've never thought a lot about boats and airplanes working against other forces, you need to think about it now. The other thing with the boats, they use the term still water. That means there's no push and there's nothing the boat's pushing against, there's nothing pushing the boat. So it's only the speed of the boat. Okay? So still water is just the speed of the boat. And these kinds of problems usually compare the rate of one thing to the rate of another. With the boats, it's the thing going upstream, the thing going downstream. A lot of times they'll give you different distances and the times will be the same, which is important. I mean, anytime you have time is the same as time, you can set everything equal to each other, which is a good thing to know. So here you'd have your basic rate. I'm sorry, I have a little dog in the room with a squeaky toy. Forgive me. You have, if the boat's going upstream, you have whatever the boat goes less the current. Okay? If the boat's going downstream, it's the rate of the speed of the boat plus the current. And that times time will give you the distance. The rate of the boat plus the current going downstream times the time will give you the distance. So go ahead and copy this. This is something you kind of need to know before we get started. Because sometimes they'll tell you the rate of the boat, sometimes they'll tell you the rate of the current. Usually they give you the distance, and for what we've been doing, the times will be the same. So let's take a look at, after you're done copying, meet me at the next slide. So here we go. We have boats going upstream and downstream. So we have boat A, and we have boat B, and we have rate, and we have time, and we have distance. And again, this is when setting up your little charts is a really good idea. So it says it can travel 9 miles downstream. So we're going to say this is down, and this is upstream. Same boat, different directions. Downstream it can go 9 miles, and in the same amount of time, so times are constant, that it can travel upstream 6 miles. So they're telling you if the speed of the current is 3 miles an hour, speed of the current, is 3 miles an hour, what is the speed of the boat in still water? So the speed of the boat without any push or pull. So remember, here we have the speed of the boat, and here it's going downstream, so it's going to be plus the speed of the current, which is 3. And here it's going upstream, so it's fighting the current, so it's going slower, so it's minus 3. And when you have that information, you actually have enough to find out quite a bit because these are the same. So if you know that rate times time equals distance, you also know that we can figure out time equals time. So time equals distance divided by rate. Okay, here's our rate. Here's our distance. So we know that 9 divided by r plus 3 equals time, right? And, oh look, time's still the same. So it equals this one, 6 divided by r minus 3. Because again, this is distance divided by rate, and this is distance divided by rate. They're both time. And that's why I can set them equal to each other. Okay, so let's do the math. And we're going to use, just like we did before, we're going to use cross multiplication because we're working over an equal sign. We can do that. So first we're going to go this way, and we'll have 9 times r minus 3 equals, and now we're going to go this way, 6 times r plus 3. 9r minus 27 equals 6r plus 18. I'm going to get all my variables on one side, and I'm getting ahead of myself. 3r minus 27 equals 18, and now I'm going to get all my numbers on the other side by adding the opposite. So 3r equals 45. Divide both sides by 3, and I have r equals 15. So that's the basic. If we go back and look at our original setup, the original rate of the boat, the speed of the boat in still water, not adding or subtracting anything with the current, is r. And over here I have r equals 15. So that tells me that if our little boat is just sitting, it's not going through, it's just crossing a lake, there's no current, it's going 15 miles per hour. Okay, go ahead and stop and copy, and I'll see you on the next video.